In this video, I want us to talk about how to simplify rational expressions. A rational expression is basically an algebraic fraction. When we see the word rational, what that indicates is that we're going to be dealing with fractions. And so the first one that I want us to look at is 3y plus 18 over 2y plus 12. So I don't want you to be scared of the way this looks. It looks like it would be bad. I know people are terrified of fractions and that kind of thing. But really it's not going to be difficult. So all we're going to do is we're going to start by factoring both the numerator and the denominator. So in this case, the numerator has a greatest common factor of 3. And so we're going to factor that out. And then when we do, remember we're dividing that out of both those terms. So 3y divided by 3 is y. And 18 divided by 3 is 6. And so the numerator has now been factored. On the bottom, there's a greatest common factor of 2. And so we're going to do the same thing. We're going to factor out a 2. And when we divide it out of both of those terms, we're going to end up with y plus 6. Again, just dividing the 2 out of each of the terms, the 2y and the 12. Now, when we get to this point, we're looking for factors that are both in the top and in the bottom. So if you notice here, the 3 and the y plus 6 are both factors. And then on the bottom, the 2 and the y plus 6 are also both factors. Notice the y plus 6 is a quantity. It cannot be separated. It is a factor. That factor is made up of 2 terms, but together it's a factor. Again, it cannot be separated. So what we'll notice is that there's a y plus 6 on top and there's a y plus 6 on the bottom. That is the factor they have in common. And so y plus 6 divided by y plus 6 is simply 1. And so typically what we say then is that those two quantities are going to cancel each other out. Now notice that the y does not cancel and the 6 does not cancel, but it's the whole thing y plus 6. That whole quantity is what gets canceled out. And so once we do that, then whatever's left is our final answer, which in this case is 3 divided by 2, or 3 halves. And so there's our final answer. That is our simplified version of this expression. So the next one I want us to look at is y squared minus 7y plus 12 divided by y squared plus 3y minus 28. So again, the very first thing we've got to do is try to factor. One of the mistakes that people make a lot of times is they look at these two trinomials and they do things like, well, this y squared and this y squared, they cancel each other out. And that is not the case. They also maybe look at this y and the 7y and the y and the 3y and they say, well, those are going to cancel out. That also is not the case. Before we can cancel anything out, we have to factor first. So I tell my classes all the time, factors will cancel, terms do not. And that's really important. If you're taking notes along with this video, you may want to make a note of that factors will cancel, terms do not. And so in this case, before we can try to factor that, we need to first factor before we can simplify. And on the top, that is a trinomial that can be factored using reverse FOIL. And so if you'll remember in our reverse FOIL method, we're going to factor that into 2 binomials. The first term is a y. And remember, we're looking for 2 numbers that are going to multiply to give 12 that are going to add to give 7. Again, not worried about the negative there, just add to give 7. So 2 things that multiply to give 12 that add to give 7 will be 4 and 3. And then our signs, because this addition sign here, because it's positive, that tells us that the 2 signs in our binomials are going to be the same. And then this first sign, the negative sign in this case, always goes to the biggest number. So our 4 is going to be negative. Since the signs are the same, the 3 is going to also be negative. Now, on the bottom, we're going to do the same thing. So we have a trinomial. Again, it can be factored using reverse FOIL. And so our first term is y. This time we're looking for two numbers that are going to multiply to give 28, that are going to subtract to give 3. So two things that multiply to give 28 would be 7 and 4. And 7 minus 4 is 3, so that's going to work. And again, this sign now, because it's negative, tells us our signs will be different. This sign goes to the biggest number, so that addition sign is going to go to the biggest number, which is our 7. Since the signs are different, the 4 will get the negative sign. Well, now, since we have this, since we have it factored, we're ready to try to cancel stuff out. If there is a factor that is on top, that is also on the bottom, then we're going to cancel it out. And so in this case, y minus 4 on top and the y minus 4 on bottom are going to cancel each other out. Notice it's not that the y's are going to cancel, but it's the y minus 4, the whole quantity. And so in this case, we're going to cancel those two out. And so what you see that's left is the final answer. And so we have y minus 3 over y plus 7. Now, notice that the y's still do not cancel. Those y's are terms. Only factors are going to cancel. So back over here where we had the y minus 4 on top and bottom, those two are factors. They cancel out. Here, the y's do not cancel. They are not factors. They are terms. And so terms can't cancel. This is our final answer. Y minus 3 over y plus 7. So I want us to try one more of these. This time we have r cubed plus 343 divided by r plus 7. And again, before we can try to cancel stuff out, we need to make sure we factor. So we're going to factor the top and factor the bottom. On the top, we have a sum of cubes. And so if you remember, a sum of cubes factors into a binomial times a trinomial. And again, I like to put my two sets of parentheses there, so just kind of remind myself what we're looking at. So in this binomial, the first term is going to be r. The sign is plus, because it's the original sign that you started with over here. The second term in this binomial is going to be a number that will multiply times itself 3 times to give us this 343. So in this case, 7 times 7 times 7 will give us the 343, and so 7 is that second term. Now to fill in the trinomial, remember that is really based on this binomial. And so first thing we're going to do is we're going to square this first term. So square the r, and we get r squared. The sign that we're going to use is the opposite of this one. And so the opposite of the addition is to subtract. The middle term are going to be these two terms multiplied together. And so the r times 7, which is 7r. And then our last sign is always addition. And then our last term, move these parentheses out a little bit. Our last term is going to be this 7 squared. And so when we square the 7, we get 49. Now, that's factored, the factor form of the top. On the bottom, the r plus 7 does not factor. So there's not a greatest common factor. It's not a difference of squares. It's not a difference of cubes or even a sum of cubes. So the r plus 7 we're just going to bring over. But remember, it's all a factor itself. So if you need to put parentheses around that, you can. And so since that quantity r plus 7 is on the top and it's also on the bottom. So you can see it here on the top and then on the bottom. That is a factor that can be canceled out. And so we're going to cancel that r plus 7 on top with the 1 on bottom. And what it's going to leave us with is what's left. And that is r squared minus 7r plus 49. And that is our final answer. Alright, so the next one that I want us to look at is y squared minus 16 divided by 4 minus y. And we're going to do this one just like we've done all the others. We're going to start by factoring. And so on the top, we have a difference of squares, so we can factor that. It's going to factor into y plus 4 times y minus 4. And then on the bottom, you'll notice that we only have the 4 minus y, and that doesn't factor. There's not a greatest common factor. It's not a difference of squares. It's not a difference of cubes or a sum of cubes, and so it won't factor. We are going to bring it on over. Now, as you look at that, you may notice that the y minus 4 and the 4 minus y are very similar. They have the same terms, but if you look closely, you'll notice that on the top, the y is negative. And then on the bottom, the y is a positive. And on the bottom, the y is a negative. And on the top, the y is a positive. So they are actually opposites of each other because they have the exact opposite signs. And so to be able to make those be the same, all we need to do is change the signs. Well, by factoring out a negative 1 as a greatest common factor, it will allow us to change the signs. And so what I want us to do is on the top, we're going to factor out a negative 1 out of this y minus 4. So you'll notice that what we're going to do is we're going to take a negative 1 out here, and that's going to change this y to a negative and this 4 to a positive. So when we do, it becomes a negative y plus 4. And then we still have that y plus 4. The y plus 4 is not changing, and so we're just going to leave it. But now, the y, negative y plus 4 and the y plus 4, they're not the same thing either, because this y is positive and this y is negative. And that's okay. But now, on the bottom, we still have this 4 minus y. So notice that on the bottom, the 4 minus y and now this negative y plus 4, they're really the same thing because the 4 is positive, the y is negative. So this is really a negative y plus 4, and on the top we have a negative y plus 4. And now that they're the same, they can cancel out. They're both factors. They can be canceled out because that 4 minus y divided by 4 minus y is 1, and so it does cancel. And so what's left then on the top is this negative 1 and the y plus 4. Now, we don't really want to leave that as negative 1 times y plus 4. What we prefer to do is clean that up, go ahead and distribute that negative back in. And so what we end up with is a negative y minus 4. Either of these answers are acceptable. I'm okay with either one of those. If you were to put either of those on your test or either of those in your math lab, you will have an answer that is correct. If you were to miss the problem, say on the math lab, what your book will show you, or the math lab will show you, is that this answer is the correct answer. This one's acceptable too, that has this negative 1, but just want you to see that they are both acceptable. They are the same exact thing. And that wraps up simplifying rational expressions. So just to sort of recap, in every one of these we're going to factor. We're going to cancel out whatever factors on top and bottom. and then whatever's left should be our final answer. So hopefully at this point you can now simplify a rational expression.